Okay, it's Mr. Gibson. I'm going to show you guys how to find the derivative of a function using the definition of a derivative. Real quickly from class, a lot of action going on in this, but where the definition of derivative comes from is from this definition of an average rate of change, okay? Or the slope of a secant line right here. We got 2 points, x and f of x, and x plus h and f of x plus h, okay? Those are 2 points along this function f of x. To find the average rate of change, we just use the definition of a slope. We have y2, which is that, minus y1, which is that, x2, which is this, x plus h, minus x1, which is just x. Simplify that, and we've got this right here. Now, the idea of a derivative is if we wanted to find the slopes at any point along this function, okay, we would want to get a secant line that had an interval of basically 0, okay? Well, of course, you can't calculate something with a 0, okay, or a slope with an interval of 0. Well, we can calculate something that's approaching 0 with our idea of a limit, okay? So the limit of basically this average rate of change gives us what's called an instantaneous rate of change, because it's a rate of change at a specific point, or at specific points along the f of x, and it gives us these tangent lines right here. Okay, so this will give us the slope at any point along that function. Okay, so that's our basic definition of a derivative. So we're going to use this definition to find derivatives of different functions. All right. So let's first find the derivative of this, okay? I saw some of you guys say that this one seemed confusing to you all. So let's put in the definition here. H approaches 0 of f of x plus h minus f of x over h. Okay, so let me plug this in. I'm going to have 1 over x plus h squared, okay, that right there, minus x squared all over h. Okay, now what I'm going to do is I'm actually going to have common denominators, and I'm going to add these together. Okay, so that gives me limit as h approaches 0 of x squared over x squared times x plus h squared. All right. Common denominator with both, so I have minus x plus h squared all over h. And in fact, let me rewrite h divided by h as 1 over h, okay? So let me go ahead and simplify this just a little bit more. Have x squared, going to multiply x plus h times x plus h, which will give me minus x squared plus 2xh plus h squared, okay? Didn't show you guys the work on that, but I'm just multiplying x plus h times x plus h. Then I have h, x squared, x plus h squared, okay? Distribute the negative in here, so it's going to change the signs. So everything will be minus. And when I do that, look, those two cancel. And I'm left with limit of h approaches 0 of negative 2xh minus h squared over h x squared x plus h squared, okay? Now, have an h in common there. Let's factor out the h. So I have, or actually I'll factor out a negative h. So negative h, have 2x plus h, and still over this h, x squared, x plus h squared. We're still going to eventually find the limit as h approaches 0. These h's cancel because everything's multiplied down here, and this is multiplied by h up here. And so we're left with this limit as h approaches 0 of negative 2x plus h over x squared x plus h squared. By substitution, we're going to substitute in 0 for h. That'd be plus 0 plus 0. So we're left with negative 2x over x squared. A couple of these x's cancel, and I'm left with negative 2 over x times x squared, which equals negative 2 over x to the third. Okay, that is our derivative. Okay, just had to get the h by itself. Kind of crazy math going on right there, adding some rational expressions and all that good stuff, but we come to this. Okay, next one, we're going to find a specific slope at a specific point. So we're going to need to find the derivative of this. And here I'm just going to cheat and give you guys the derivative of this. This is actually a symbol for derivative. This little prime right here. And it's just going to be negative 2x, okay? I'm just going to give you guys that. Because what this gives us is actually the slope at any point along this function, okay? So to find the slope at this point, we just need to take 1 and plug it in for x. So this will equal negative 2, oops, my bad, f prime of 1, my bad. So I'm plugging in a 1, so f prime of 1 equals negative 2, okay? So this is, to find this, I would find the derivative of this, but I just didn't want to waste time on that. So I went ahead and gave you the derivative, and you just plug in the x value on that point. And so we know that at point 1,3, the slope is negative 2, okay? I'll upload these notes and do the assignment. Thanks.